Hi everyone, welcome to TechTuber. So in this video, we're gonna talk about how asynchronous JavaScript really works. Like, JavaScript is a single-threaded language. Means code is being executed in JavaScript engine in a single thread. So how asynchronous JS really works if there is only one thread? So how asynchronous JS works in a non-blocking way? Is JavaScript really a single-threaded language or is everyone lying? If you want to find out all the answer about this confusing topic and want to be on the top 5% of JavaScript developers, continue watching. If you already know, still watch it. Eventually you're gonna learn something new. As you can see on the screen, I have different components here. JS engine, web API, micro task queue, callback queue, and event loop. So these are the part of JavaScript runtime. Okay, so what is JavaScript runtime? It's actually a container which contains different pieces to run a JavaScript code. Okay, so I will explain you one by one about all of these components. Like here we have JavaScript engine, which is the heart of the runtime. So as JavaScript engine contains a call stack, so code is being executed here. Okay, so that's why it's the heart of the runtime. As you can see, it contains a call stack. So code is being actually executed here. And as I told you previously, JavaScript is a single-threaded language. So it's gonna execute it in a one thread only, and there is no multitasking here. And next we have web APIs. Okay, so web APIs contain different APIs like DOM, fetch, timeout, and it's gonna provide all these API to the JavaScript engine to actually run in a call stack. To explain you further, I have a little snippet and we're gonna run this snippet and we're gonna eventually know how asynchronous JavaScript really work. Even there is one thread of execution. So first we have document.querySelector. It's gonna come in a call stack and it's being executed in a synchronous way. And second, we have image. So image is being loaded. So should it be loaded in a call stack? Like if we have a very big image and it's eventually might take some couple of seconds to load. Should it be there in a call stack? Like if it's keep on loading in the call stack, and eventually it will block all the code below it. As you can see, the rest of the code will not execute before the image is being loaded. So image is not loaded in a call stack, it's actually being loaded in a web API environment. So web API is an environment where asynchronous tasks actually run. So image is gonna load there, okay, and then we have add event listener. Image is being loaded asynchronously side by side. And when I say image is being loaded asynchronously, then you might think like I have just wrote image.src. So it's the default behavior from JavaScript to actually load image in an asynchronous fashion, not in a synchronous fashion. And it's by design. And I told you why JavaScript load this image asynchronously. Like it will obviously block the rest of the code for a couple of seconds if image is really large. Okay, so add event listener, this listener is being registered here in a call stack, and the callback related to it, that image is like we have attached an event listener to the image and there is a callback associated with it. Like after it's being loaded, then this callback will run. So after registering in a call stack, the callback actually sits in a web API environment. So until the image is being loading, the callback it just sits in this web API environment. And after that image is completely loaded, the callback from the web API environment come to the callback queue. That's why it's called callback queue, because all the callbacks from the web APIs eventually come in the callback queue. So from the callback queue, now we're gonna see how it's being executed. And the main part that actually helps here to run this callback is event loop. It just pick up the callback queue, it just pick up the callbacks from the callback queue and execute in a call stack. So first it will check if the call stack is empty, then event loop pick the callback from here and just execute it in the call stack here, like you can see. Okay. And then images call stack, it just runs in a call stack, code is being executed and then done. And next we have this fetch. Okay, so before moving to fetch, I'm gonna tell you at another, like we have like another asynchronous task like timeouts. Okay, so for example, if you gave a timeout of like kind of say 2 seconds, so these it's actually an asynchronous task. Okay, so it actually just sits in the web API environment like image is being loaded, so it's same way the timeout also sits in the web API environment. And after like waited for 2 seconds, the callback from that timeout comes to the callback queue, like we saw in an after the image is being loaded, the callback from the image comes to the callback queue. But let's say we have some couple of callbacks already in the callback queue waiting for their turn for being executed by the event loop, and the event loop just picks the callback and then they will execute in the call stack. So in the same way, like other callbacks, the callback from the timeout also waits here, but actually the callback from the from that timeout will come in a callback queue after 2 seconds. And if there are some callbacks here in the callback queue, then it will wait a little longer then. So the timeout doesn't guarantee us that it will exactly take 2 seconds. It will just give a guarantee kind of thing for like it will take minimum 2 seconds, not exactly 2 seconds. Obviously if there is some code in the callback queue, so that code will run first in the callback queue, and then the callback from the timeout will run. Okay, if you don't understand this, just please listen to this again, you will eventually understand. And next, this fetch. So I have taken specially this fetch function separately because for fetch there is a promises associated with it, like internally promises are being used. So what are promises? If you know, well and good. If you don't know, then promises actually is kind of like a container for the future value. Like some result is gonna come here from future. It's just a container for that. I will post a separate video for that to make you completely understand about the promises and all that Ajax calls. I will let you know. Okay. So here the fetch function comes and it's an asynchronous task, like an Ajax call is being made. So what, like from previous learning, what should you think? Should it be run in a call stack and block all the code? No. It's being executed in the web API environment. Okay, and the callback from it also sits here. Okay, so as soon as that promise is being resolved and that, then the callback will be called. So the callback from that Ajax call is just sits there. Okay, waiting for the fetching function to actually complete. And then when fetch function completes, so what do you think it's gonna come? in a callback queue or something else. So in fetch function, the callbacks actually come in the micro task queue. So micro task queue is kind of like a VIP line which is being executed first before the callback queue. So before moving to the callback queue, event loop actually checks if there is any callback in the micro task queue. So for promises, this thing works in a slightly different way. Okay, so event loop first checks in the micro task queue. It just picks all the callbacks from the micro task queue, executes them one by one in call stack, and then it checks the callback queue, like if there is any callback there. So the priority is given to the micro task queue. It picks up the callback from the micro task queue, execute it in the call stack. Code is being executed in a single threaded way in a call stack. Okay, and then so as you can see, JavaScript actually is a single threaded language, but the asynchronous task is actually being possible with the help of this web API environment, micro task queue, callback queue, and the event loop. These all components make it really possible to run an asynchronous code in a non-blocking fashion. So I hope like you can now really understand how asynchronous JavaScript really works. If you don't know about promises and that Ajax call, no issues. Just let me know in the comments. I will post a separate video for all these things. Okay. If you want a complete JavaScript course or just complete asynchronous JavaScript course, just let me know in the comments. Okay. So if you really like this video, just hit a like button, subscribe to this channel. A lot of videos gonna come here. Okay. So now with this understanding, you are eventually in the top 5% of the JavaScript developers. Like most of the devs actually don't know how these asynchronous JavaScript code really works behind the scenes. Now I hope like you probably have a more confidence to ace any JavaScript interview. Okay, if you have some doubts, just post the comment. I will answer all the comments here.